this is not high resolution. This is not Ferrous data. This is low resolution. Is a data that we got with the 1.5 meter is spectrophotometry basically,
Okay.
and is a low resolution. It's about I think 2 angstrom, something like that, or 1 angstrom. Okay, so now I'm passing that to Juan, and I'm taping. So
Okay.
yeah.
So first, well, you have to have the files downloaded first. I installed Nuiso and I put it into this this path users by heart. I don't know what's about your if your path is similar to mine, but you gotta make sure. Yeah, you have to start including it into path. And after you've done that, you pretty much can do anything. Say for what is it? Oh yeah, and you can plot the graph right here. Wait, can you see the graph?
Yeah.
Yes. Okay. Yeah. It's pretty much simple. You just gotta direct it towards the correct path. And after you've done that, you can pretty much plot everything and mess around with it. Wait, does Kitana downloaded the files first? Files yet? I was curious.
I have IDL downloaded, but I haven't ran it yet.
Oh, okay. But did you download the files that he sent you?
I didn't get any files.
I'm gonna go to Dropbox and open and allow you to. Let me get your email. And Cortana.
Is that the same Dropbox that I put the files in?
Yes.
Okay.
Okay, so let me go to Dropbox. Contents.
Those are just in FITS format.
No, in fact, it's not. Wait a second.
Unless you loaded the save files.
No, it's not in the EX. Let me see. News. So I have one with the IDL. Wait a second. Just a second. TTS. You are the owner. Oh, there you go. Okay. So the name of the folder is TTS. Lee, I'm gonna share with you as well. So let me share with Cortana. And what?
Oh, okay, I got it.
You got it? Now let me share that with Mr. Lee Rottler. Lee, what is your address? Is LR?
I think it's L Rottler.
L Rottler.
Oh, you mean my Gmail address?
Well, could be.
Yeah, my Gmail address is, or my email is clrottler.
Oh, you got it.
At gmail.com.
Okay, you're there. So in this folder, I have a routine that I just built quickly, and that's the one Hong show. The only thing it does, you give a catalog number or the number of a catalog because, I'm not sharing. Let me share my screen here just a second. Share screen.
What am I looking for? Oh, I'm okay.
So this is my Dropbox, and you go. So the folder is TTS. It's right here. And this is a routine, the one Huang show. The only thing it does, it gives you give a catalog number, and it pull up W and S, which means wavelength and flux. And UISO is what it is. So this catalog data, it gives you. Let's see if I can open. I don't think I can open in Dropbox, can I? No, I don't.
No, I don't think so.
Yeah, let me.
You got download it first, so.
Yeah, so let me get out of. So let me show the routines here. Take this away, this away, this away.
Well, this took over my screen. I can't get.
Open. In fact, let me go here. Documents. I think it's this one. Tutorial. Yeah, so the catalog is that's how I thought the best way to organize the data that I observe. I don't know if it was the most clever one, but I got all the observations. This is a record number, and this was supposed to be range of velocity, the number 0, but I never did correction because I didn't need it, so I didn't do it.
Okay.
And here I have the name of the star, which AS205, and this extension here, I don't know what it is. That's BZ Sagittarius. I have tons of it because the star so exciting, has so much thing going on. CS Shah, CT Shah, EG 274, Eta Carini. There's a bunch of Eta Carini here. EX Lupi, and so on, so on, so on. So that goes the star. And 31 and 33 is the type of setting that I had. 31 and 33 takes more of the ultraviolet, and the setting that's the order of the spec. Is a window that you can set the spectrophotometer to observe. So as far as I remember, the 31 and 33 would give me a nice view of the Balmer jump all the way to 5,000 angstrom. And this 23, the 23 setting would give more of the optical range from, I don't know, 4,000 all the way to 8 or 9,000, but with more degraded resolution. So even worse than the 31. Data of observation is here, and the name of the star is there. So that's the catalog. And so, but what I did, just to save time, I create every single observation with a binary file, which is an IDL binary save set, SAV, with this extension. So stars, because the star 86 is that catalog number. So what I did, for each star, BZ Sagittarius and CS Shah, EX Lupi, so on, so on, so on, I create a save set that has the record number of those stars, so you don't need to keep looking for them. And that's what Huang did. He went to his IDL, and then he restore, let's say, restore BZINDBZSGR. I think that's what it is. It's BZ what? It's just BZ? Maybe?
Yeah, there
busy.
you
Yeah. So if you do a help IND, so you have 33 possible records, and then you can read them all, and that's gonna be busy Sagittarius. So when you go back to the routine, so this is a loop that is say, okay, go all through the number of elements minus one and begin, take the star, read the star out on this record and plot. And wait 1 second just so you can see what's going on. And then when you plot this, you should have your busy Sagittarius coming out, I think. But now I lost my windows. Oh, there you go.
go. Oh, there it is.
Yeah, so it's coming there.
Yeah. Okay.
But it's not coming. What happened? Did I get an error message? Oh no, I didn't play return. Okay, there you go.
Too many windows.
Too many windows. So you see, the busy Sagittarius gives this nice inverse Psigan profile as well, right? Look at that. It's crazy.
Yeah.
It's really crazy. And this star was not so much observed. Later on, as far as I remember, I mean, I got this star quite by chance. It was one of those stars. Loops and Chameleons had passed away, and then 4 in the morning, we didn't have more star. And then I found one catalog that lists this star as a possible Titori. And then when I observed, it was amazing to see the inverse Psigan profile. It's an isolated Titori in the Sagittarius cloud. And later on they found a bunch of companions, so it has a bunch of companions now.
Oh.
Yeah.
So that the P Cygni is right beside this.
In the H beta you can see quite well. So if you let me see if I can do it. Put a range.
It's pretty broad.
4,800, 5,100.
It has nothing to do with H beta, right? Or is it H beta so narrow?
Not really. It depends. Oops, I did some boo-boo here. Wait a second.
Oh, it's a scale problem?
I forgot to put an equal. So look at that.
Oh, I see. Okay, that's clear. Okay, I see it.
Now it goes away. So you change the wind, or you change the viewing of the inflow, and then you see this narrow component coming up. And I mean, it's a mess. It is a big mess there. To interpret this is it's an exciting thing. And there are some stars like RU Lupi that is always this broad emission. And if you go to the high resolution Pharos, you'll be amazed with the broad line, and then you can devise a couple of components, one very broad and one kind of a tending to be narrow. And it's kind of a tricky.
Are the lines representing flux emissions?
All those lines are in flux emission, and they are. So let me show here. If I take this division, if I don't normalize them, now it's being plotted in flux. So this number here, 10 to minus 14, is the flux we received on Earth after done calibration in the sky. So the calibration in the sky when we do with spectrophotometry is you observe the star, your star, and then you assume the sky is sort of a clear. And most of the times it's not. So to do a very nice spectrophotometry, you should observe a bunch of standards, which I didn't do. That's a flaw in my data. But basically what you do, you take your star and then you observe the flux you're receiving in your detector, and then you have ways to convert the number of photons received to a certain intensity, right?
Okay.
And then what if we know how far the star is, we can convert that to flux the star itself is sending. And since we know where these star forming regions are, how far they are from us, we can estimate how much energy is coming out of the star. So yes, this emission here is an emission in amount of energy coming out of that region. And whereas
Not the
this,
star, the region.
well, the star itself is producing most of this part of the spectra here. When you look at the emission is not stellar, it's circumstellar. So it is something that's going on around the star. That
Okay,
yeah. So imagine if the star is 1 inch and the circumstellar is 3 or 4 inches, so that is gonna produce much more radiation than the star itself, and then you have these peak emissions there.
okay.
It is quite cool, and what we attempted to do at that time is to do what's called um, uh, observations with some cadence. We try to observe, every day for 11 nights, and we would get chunks of 11 nights and try to observe, one time every night. Um, Sometimes we try to do more, and what we try to do is, if within those nights, if we detect some periodicity, then we could associate that with the stellar rotation, or perhaps with the region in the wind that is producing um, that emission. And then we would try to see if there is some periodicity in the emission component and the stellar component. And so those two regions would be connected like a dumbbell, right? So we have one part of the dumbbell in the star, another one in the circumstellar region, and then they would be kind of moving together as the star rotates. So all of that is a lot of details that this data can give.
Okay, thank you.
Yeah. So, Kirtana, I'm gonna send you a file that I sent Juan that might help you to kind of orient yourself, and once you have what Juan has now, which means being able to plot things, then you could start, be a little bit more on top of the game. And once you guys are kind of excited, and then we can start exploring and collecting data out of this low resolution string of data. And
Okay, so is it gonna teach me how to use IDL? Because
teach how to do what?
is it gonna take me through how to use IDL?
Yeah. Do you have any computer experience? Did you take any Python class or?
I know Python, Java.
Oh, geez, you are better than I am.
Oh, okay.
Probably not as much as Lee Rotler, but
Yeah, probably not.
But you should be fine. Yeah, you should be fine. You guys should pick up quickly. I mean, ask Juan. Juan, what do you think?
Well, it's actually pretty easy to get it figured out, so you should be fine.
Okay.
Okay, that's good.
Okay.
Yeah, IDL is pretty easy to pick up.
Yeah.
Especially for stuff like this.
Yeah.
Yeah, I think my mom knows how to use it, so I'll probably ask her.
Oh, she does?
Yeah.
Where did she learn IDL?
She's a programmer, so I don't know where she.
Oh, man. We should consult with
she's
her
a
as
software
well.
engineer
Oh, okay.
at IBM.
Yeah, IDL's been in use for a long time.
Yeah.
And astronomers were a little slow, but then they kind of started using it at the 100% level. But now they're switching over to Python.
They are switching. Yeah, Natasha, when I bought IDL, Natasha said, "Why did you do that?" And I said, "Because I learned before, and I don't want to learn Python right now." And then she said, "Oh, okay." all these exoplanet codes that she's developing is in Python. It's not in IDL. But there are other people translating all of that to IDL, and it's gonna make it
Oh,
public.
really?
Yeah.
Okay.
So that's good.
Yeah. So I kind of missed the first part because I couldn't get audio and everything
Yeah.
connected. So basically, is this the? All right, so you're starting. You're starting some projects and with people in the. You said they're. Let's see. Both of you are from high. Are you guys are seniors in high school?
I'm a sophomore.
You're a sophomore.
I'm a junior, so
What's that?
I'm a junior.
You're a junior. Okay,
So
cool.
that's exciting because I have this. If they don't fly away, you know, don't disappear, I might have them for a couple of years, which is
Yeah.
exciting.
Yeah, I'm saying, don't worry.
Yeah.
So that's pretty cool. I mean, you might be able to gin something up for like a science. What is it? What's the Intel? Does Intel still have the science fair?
Oh, yeah, I think they do.
Yeah, if you could get a good project going.
And for us at Evergreen is great because I'm trying to launch this includes grant, and in fact, in May, the first weekend in May, there is a includes workshop in Orange County, and I'm gonna go next to where you live, and I'm gonna stay there from Thursday to Saturday, and I would like to say that okay, I have two students, maybe three with Pranati. They are working with data, they are doing research, and because the idea is to be able to have this type of activity done with 20 students. And
Actually, because next year, I'm gonna be the president of the astronomy club. So if I can get more students involved in it, then we might have like 10 or 15.
that's gonna be an explosion. So, and I want to be prepared. That's the whole thing. Once you guys, I mean, once we can take as much meat, and I'm a vegetarian, but I'm using some expression here. So my Brazilian people would say to milk as much, to take as much milk of the cow as you can. So out of this low resolution data, and once we know how these stars behave, let's say that I allow or give CQ loopy to one of you, or RU loopy, or EX loopy, I mean, to one of you, and you guys study the star, see the behavior, and have a good idea. What I would like you to do next is to move on to ESO data and collecting data, high resolution data, which means you have much more information than what you have right now, and then we start to do animations. So at your level, I don't want you to get too trapped with the physics of it, but you guys can do nice animations. You guys can work in correlating processes that are going on in one line with another line. So when one line goes in peak, what happened with the other line, the one that probes perhaps winds? So if the winds goes flaring, that same thing happened with the part of the spectra that goes in or indicates photosphere. So what's going on in the chromosphere? So do we have some consistent correlation with all these different factors? So and that's that part. When we get to that part, then you guys can be leading other students into the project, because the data is free and not a lot of people are using, because they observe, let's say, one small region, but you have tons of it available to be explored. And I would like this to be done by high school students. You know, when you guys go to college, you have a lot of experience, especially not necessarily if you want to be astronomers, but if you are going to do research in any other field, you have the skills of finding out things, you know, and using imaging process, and especially if Lee, you know, if I can fund Lee and have Lee around, that would be great.
Yeah, the nice thing is, you'll get all the tools that you need to do any kind of research in the natural sciences.
Yeah.
So, or
I actually do want to go into like astrophysics, so this is a good experience.
Mm-hmm. Yeah, the other thing though is since there are not a lot of jobs in astrophysics, unfortunately, the skills that you get that you're using to analyze astrophysical data can be used to analyze almost any other set of data as well.
Yeah.
Yep. Yeah. Absolutely. All right. Okay. So then it's 7:48. I don't want to keep you guys too long. And let's close the bar.
Okay.
All right. Lee, are you saying something? I can't hear you. I can't hear Lee. Lee,
You're sometimes breaking. Oh, okay.
can't hear. Okay, I will write in ideal. Lee, I cannot hear ya. Command not found. Well, okay, all right. So let's try to get together again on Tuesday next week. Same time seems to be good for you.
Tuesday. I actually have like my finals that day.
Oh boy, forget it.
Yeah, it's a physics final, so
Yeah. Well, I will mail you the file, and with Juan, I will see where you are now, and I will try to be more specific and give a more specific task for you. But I will not have time until Friday to have that written. Okay. Um, and let's see where we go.
Yes.
All right.
Okay.
So, and I will send this taped lecture to both of you, to three of you. In fact, I'm going to send it to three of you, to Eduardo Ciperuelo.
I know Pranati is interested.
Who is?
Pranati.
Pranati. Yeah, I know she is, but she might be busy. So
Yeah.
I'll send it to her, to you, to Eduardo Ciperuelo, and Lee Rotler, and then we go from there. All right.
Yeah.
Okay.
All right. See ya.
Good night. See ya.
Bye.